Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my CO2 CNC laser cutter series. So basically, what we have here is I have the Trello here, and basically around this is probably going to go up to about $2,000 or so. Optimized tube wattage, gerbil, possibly. I really like that idea of being able to customize the size of the overshoot, but I don't know if they really have a lot of gerbil code available for that. So this really can change. It doesn't have to be the way it is. I believe we will use what's it called? O-Drive. Because we did prove it in the last video, which I am uploading right now. I lost internet for some reason last night, so I was not able to upload, but it's uploading right now, and then this one will be shortly after, obviously after the 30 minutes are over. So we did determine that O-Drive would work, and we see that we have a 0.001485, so 1.4 0.14 thousandths of an inch, so 1.4 tenths of an inch, which is generally these beams they have like a 5 thou focus diameter, so it's smaller than the diameter of the laser, so no problems. Right, just kind of like a pixel, as you saw in the last video, pixel on the phone. It's smaller than the pixel on the phone, so not really that big of a deal. Now, the other thing is what type of... So, basically, we have a couple things. So, parts that we need. Obviously, we need the aluminum extrusion. Wow. And then we need CO2 tube, stepper drivers. In this case would be O-Drive. Stepper motors. In this case would be brushless RC motors with encoders. Oh, and then yeah, Core XY. So obviously if we do Core XY, then we do need to use gerbil or something of the sort in order to be able to run gerbil itself and actually work. So that is something that we're gonna have to look at, because if we run gerbil, and then basically from there we're gonna have to decide. So either we have to isolate the X and the Y, or we could have both motors work to do X and the Y, and kind of because with a Core XY you have way more torque available, because now both motors are helping control that, and because in I believe pure X movement, I have my printer here. I have a Tronc C, which is a Core XY printer right here underneath my table. So I could actually kind of check and see here. Yeah, so basically both motors have to rotate in order to get it to just go back and forth on the X. So that way you have double the torque. Thus you could technically go double the speed with having the same precision. So again, I have a Tronc C 3D printer here underneath my table, which is my main printer now. And if you rotate both motors at the same time, then it will either go positive or negative on the X, depending if you're going away from each other or towards each other, pretty much. So that would be an ideal idea. So then we need a CO2 tube power supply, yellow acrylic, yellow laser safe acrylic, Hinges, obviously. So here, probably what I'm going to do is do linear rails with V-groove wheels. Just kind of like the Tronxy here. So regular Delrin V-groove wheels. That way we get nice, quiet, smooth, fast operation. And we could still get really good precision as far as having the laser still be perfectly perpendicular with the build table. Now, what I'm thinking is that kind of do the same thing like I showed in the last video, where as Boss Laser, where I just move the laser head up and down. What would be very interesting is if somehow I had some sort of station or something on the side that this laser comes and docks, and then that has a motor, a stepper motor on it, and it will adjust the Z. That would be kind of interesting. It comes back home, homes itself, a little motor comes out and adjusts the Z, and then it takes off. Because the main issue is having it go back and forth with the Z motor attached to it, because now it's got extra weight. But the other thing is that having the Z motor on the table and then having to flatten the table, because again, you want everything to be nice and flat so you don't have darker spots or uneven spots, and then your cuts will be straighter, right? So the table is going to be very, very flat. So I'm thinking that if you have the if you level out the gantry, because then basically you're going to have to do double things. You're going to have to level out the gantry, make sure that the laser tube, make sure that the laser head and focusing elements are perpendicular to the bed. And then that would normally be it if you just have a regular table. And then the laser just goes up and down. But if you have the electric table underneath, then you have to have the electric table also go up and down, as well, be perfectly level and not skew itself, because otherwise it's going to mess stuff up. And you need to give more room underneath, and you need more motors, and then you need to attach them. So generally what they do is they have two lead screws, and then they have two lead screws, and then they have a motor, and then they have one single motor, and then they belt both of them through some spur gear. They're using a belt or using a chain, a regular dual link chain. So we need to decide that whether we're going to use the Z table moves up and down, or if the head moves up and down. And the main thing with the head moving up and down is now you have to have some sort of linear rail or something on there, and you have to have a little motor, right? And so that's going to slow down the speed of doing the rastering. While this main thing is this machine's main purpose, very little cutting and a lot of time rastering. So if we look at the time, it'll probably be, I'm going to say 80% rastering, 20% cutting. Maybe even 90% rastering, 10% cutting. So it needs to have a very, very fast raster speed, and while still be able to maintain high definition of the raster, a very, very nice quality of the raster. And obviously what speeds that up is the wattage of the laser. The higher the wattage of the laser, the faster you can move, and it still maintains its darkness, because you don't want to be moving and it not be dark, basically. But you can see some comparable machines like this size. So, speaking of size, so the table that we have is 29 by 25 long, so the table is 25 deep and 20 inches tall. So we can't go over 20 inches tall. I think we should get really, really close to that, at least to the back of the table itself, What I'm thinking is that 5 inches in front of the table, or something like that, that would be where I'm thinking maybe we have the door on slides, so we actually pull the door out and then slide it up, or something like that, or something where we could get very, very, very close to that 20 inches and 20 inches tall. I do have my tape measure here, because if we have that power table underneath, we're going to have to get really, really close to that 20 inches. That 20 inches, but that 20 inches is decently tall. Now that table, I think, is almost, so my table here in this office is 32 inches. And then with 20, I could still see into, I think I could still see into the machine if it's 20 inches. So this table is 39 tall. Sorry, 32. 32 plus 20, that's 52. 52 is, it's about 4 feet and some change. So 4 feet and some change, we could still see into the machine. So even if we did 20 inches tall, we could still see in. Or what we could do is we could do even, or it's 20 by 20. So that's my sorry. The idea is I want it to be square, 20 by 20, right? So 20 inches, because the 5 inches there for the 25 deep, probably the last 5 inches at the end are going to be for the tube. So we're probably going to do 20 width, 20 length, and that should be fine. So that means the rest of the table, I have 50 inches the rest of the table. For other machines. I do plan on having other machines there. $50 inches. It's about the size of a queen size bed here. 50 inches, yeah. Okay. So I think that will work. Okay, so now the question is, okay, so here's a Resi 130 peak 150 watt. It's 165 centimeters. So what do we have here? 115. This is W6. Shh. It's W6. So here's band life 10,000 hours. Tiger. Okay. Rated power 150 watt, max power 180, full length. Oh, so this is another thing that's going to basically do a lot of this stuff, which is millimeters to inches. So here's millimeters to inches. So is length. If we have to have an extension or whatever on the end of it, which most likely we will. 1850 is 72 inches. Holy shoot. Okay, well that's not gonna work. I think these are way oversized. That's 41 inches. That's about half. So what is nice is that tube is going to be at the end of the table, and so I can have that guy sticking out to the left, and then have some sort of exhaust thing coming out of the right, or something like that, or out of the top even. So that would be okay, because basically I'm just going to have equipment around it. I might even have my computer right there, depending. So I'll just have equipment around it with that extension of that piece sticking out. So that's okay. Here it's talking about Resi 100 watt. Man, 100 watt, 1050. Okay, so here's another thing. Tubing diameter is 80 millimeters. What is that? 3 inches. Okay, so technically that means that we could have in there, so we'll have a separate room for the tube because we don't want to get any sort of soot or anything on the tube. So let's say that that was the case. And then that's probably where we'll have fans and stuff, all the electronics and exhaust fans, etc., underneath there, and be sucking the fumes out, and then pushing it out through the right side, and then out, and then probably through a tube, and then inside the tube I'll just press a carbon filter or whatever, and then spit it out through the carbon filter, either up to the ceiling or out underneath the garage door or something like that. So that's another thing, is we're gonna have to look at how to do the filtering, but we're gonna have to see what size, because this is almost half the table length, right? So this is 1050 millimeters, 41 inches, and the table length is 69 inches. That's a giant laser tube. Let's see where my table is. 41 inches. Man, I really want a high wattage, but I don't want it that way. Holy shoot. That's a giant laser tube. That's like a 3.5 foot almost laser tube. It's 1 inch away from being, it's actually 3/4 of an inch away from being almost 3.5 feet. That can't be right. That has to be a typo. So let's look elsewhere. Oops. And you saw the price, obviously. Okay, yeah, so this is 1650. That's 64 inches. Holy. 64 inches. That's 5 feet, almost 5.5 feet. 64 inches. It's like that's the width of a queen size bed. That's how big that is. Okay, so we're just gonna have to deal with lower wattage. That's just how it's gonna have to go. So we're not gonna be able to do sheet metal here, it looks like, unless we somehow split the thing into multiple pieces. So let's drop it. Let's look at 130 watt. So they're saying 130 watt could go up further. So let's look at 100 watt. Length 1450. It's 57 inches. So what do we have to be down to 22? 500 millimeters. What is that, 60 watt? $1,250. Man, I don't remember these ones being so long. Okay, here's 1,000. But 60 watts way too low. $1,250. Because basically what this guy is designed to do is it's designed to cut plywood, which is bamboo plywood, right? 3-ply, 1/4 inch thick, and with plant-based glue in between it. Now the pieces it's designed to cut are 12 inches by 12 inches, right? So now it's like, how much room do I actually want to take up? Because this other one, basically the whole thing goes all the way down the table, the 150 watt laser tube. Right? But you can buy one for $850, which is not bad. shipped, $850 shipped. But sometimes they end up, when they get here, they're broken. There's 10,000 hours. Okay, so let's look at that boss laser again. There's got to be something that was strange there. I'm pretty sure his was like this one or something. What's the machine dimensions? 81 inches. Wow, that's about the size of a mill, a Tormach almost. Tormach's like 15 inches bigger than that, about another foot bigger. And then so you gotta kind of assume, yeah, the tube goes basically that far. So that is 81 inches. It's about 20, it's about 20,000. So I could theoretically make that one right, 1650. Yeah. So I could make this one with like 5 inches to spare. And then basically the laser will come out of the right side and then it will go off to the left. Or it could go off to the right and comes out left side. One or the other. I'll probably have it on the left side because that's where I'm going to have my water jet, my mill, and this guy. So I'll probably have it on the left side, tube coming out of the right side, and then laser going to the left and bouncing in and getting redirected and shot down. But I gotta have at least, I think at least 100 watt. So this is 1200. This one is 1450. I mean, really, the only way to look at these is you have to look at the it is basically the length. The length is pretty much only thing that you could really look at to judge this kind of thing. 125. It's about 20 inches shy. Because another thing that I was thinking about doing was basically doing the full shelf laser cabinet where basically I what's the word I'm looking for? Where basically I have this tube up on the ceiling, up on the back ceiling of this shelf. So basically, so here is my shelf, for example. So here's the top, and here's the bottom. And so like here's the next shelf above it. So this is the shelf that it's gonna go on, and obviously it's 69 inches. And then have that laser tube just go all the way in the back corner. So if you were looking at it from my garage side, my garage door side, here's the shelf, and here's the shelf above it. The laser tube is here. So now you have the rest of this space to do whatever you want. So I think that would also work. And then you have an extremely fast, extremely high wattage laser, basically. And I've used this boss laser with my boss as well, kind of strange. My manager, I guess you could say. And it's extremely powerful. So I need to basically spend the time to decide which one 150, if I go 150 watt, because basically they're all long. And you can't really do a yeah, so these are all low power, 500 milliwatt, half watt. So I think they have one, I'm pretty sure I remember. There's 2 watt. I don't know even how. Yeah, so like here's an idea of something else that you would use would be like a some sort of diode laser, but obviously way heavier. Yeah. Anyways, so definitely a couple things to think about on how to really only 15 watt. There's not really any other way of doing it that's easy to do and not ridiculously expensive. So you have either some sort of diode laser or you have a C02 laser. I mean, there's other ones, YAGs and all that stuff, but way too expensive to run. So here's a 60 watt. Because originally I was just going to get a 60 watt. This is 115. It's 45. Even a 50 watt laser tube is 800 millimeters. That's 31 inches. But how much can you actually cut? Can you actually cut with the 50 watt? The things that I need to cut? I mean, it could be one of those things where I buy it, if it doesn't work, I get rid of the power supply and get rid of the power supply and get rid of the tube, you know, to somebody that needs a spare one or whatever, and just get a higher wattage one, you know, 100 watt or whatever, right? Yeah, here's a high 50 watt laser, 808 nanometer for $7,000. Yeah, that's not gonna work. Anyways, yeah, so maybe I could do some more researching and figure out if something like a 20 watt diode laser would be able to punch through it. or the 50, even 40 watt. What about a 40 watt laser tube? These are for really extremely cheap machines. It's a 700 millimeter, so that's about the original length that I was thinking. As you can see, you kind of have 90, and then it goes from 800 to 1,000. So you really have some diminishing returns as you get big, as you get longer and longer. So that's something that I will do more research about the Plyboo and see what is really necessary as far as power to cut. So I will do that and find out, because obviously if that was the case, I could build something with this for extremely cheap. Obviously it's going to take way longer to do the rastering, and whether we're actually going to be able to make use of that speed. Obviously we'll run rastering on full blast, but whether or not we can make use of the speed of the O drive is another story. Alright, so I'll do some research, and I will catch you guys. I'll probably do some catch-up videos this weekend when I have a chance. So stay tuned for that, and I will see you guys in the next video. Thanks for watching. Take it easy. Peace.